Okay, welcome everybody to this webinar on master's program in electronics and nanotechnology. So this is one of Aalto University's master's program, and we are here to introduce the program, talk something about Finland and Aalto University first, then some program overview introducing the majors, and after the presentation we also have a student experience. So a student Gayangana will talk about his experience as a student, and at the end we will have a questions and answers session and some practical information for those who would like to apply. So my name is Markku Sopanen. I'm a professor. My field is optoelectronics. I'm the program director at the moment. So I will talk about the program. Jenni Tulensalo is our planning officer. She will handle all the practical things related to students and administration of the program. And then we have Gayangana, who is one of our students, second year student, studying microelectronic circuit design, and he will talk about his experience about the studies here in Aalto University and Finland. So Aalto University is fairly new university, but it is based on a long experience and long history of three older universities which were merged in 2010 to become Aalto University. So the main idea about forming this university was to promote innovation. So Helsinki University of Technology is the oldest, but it has all the technological fields represented, and so has Aalto University also. Then it has been combined with University of Art and Design Helsinki, which is quite famous in for instance clothes design and other design aspects. And then we have Helsinki School of Economics, which brings the sort of the business experience and business fields into our university. So we have been existing 14 years and trying to more and more combine these fields together to support startups and Finnish industry in general by having this multidisciplinary approach. Finland, or the Aalto University is #1 in Finland. Helsinki University is another one which is very highly ranked, and depending on the rankings, Helsinki University is sometimes #1 in Finland, but in this OS World University rankings, Aalto is #1, 113 globally. Very high industry collaboration, 21st in the Leiden ranking, and also very international. Almost 1/3 of our students are international, at least in the doctoral level, maybe even half of the students at the doctoral level are international students. So the further you go, the more international students you find. And Aalto University is located in Espoo, the city of Espoo, which is left on the map here. The Aalto University is also very much in collaboration with VTT, which is the Finnish National Research Center, focusing on supporting Finnish industry through research projects. And in that sense, the education part is the Aalto University's responsibility, but VTT does a lot of company-related research work. We are in Otaniemi area. Close to us is a Keilaniemi, which is a business district where many biggest Finnish companies have their headquarters, like Fortum, the energy company, and Nokia used to be there. Nokia was at time the biggest Finnish industrial player. It has moved to a different location now, but Nokia used to be in Keilaniemi area. Close by is also Helsinki. So right on the map you see the city of Helsinki, which is the capital of Finland and the largest city in Finland. And together this capital area has about 1 million people. And in Helsinki, there is a very big health campus in Meilahti, and also our programs are partly leaning on collaboration with the hospitals and medical research centers in Meilahti area. And then Helsinki Center and Ruoholahti, there is a lot of business-related activities, and our business school originally was located close to Ruoholahti, but now has moved also into our campus area. And there are several startup hubs in the capital area. Maria is one, and then there is also a lot of startups in Otaniemi area close to the university. The Aalto campus has been integrating all these fields, technology, arts, business, into the same campus in Otaniemi area. And this is a great place to meet people from different fields, and there are some project work that can be done with a multidisciplinary approach, and also some of the projects are related to real business cases from real Finnish companies. Learning spaces are roomy. There is a very nice library. We have student hubs for and rooms for independent work, so you can borrow some rooms to do group work or just hang out with your friends and study. Lots of laboratories, experimental equipment, and so on. And for students' private life, we have a affordable student housing system, different fields of science have their different guilds, and the student guilds have their own rooms, usually in the university spaces. There are event venues, sports facilities, and of course in Finland we have lots of saunas and so on. So there are a lot of opportunities also in the free time. And the capital area is very rich on restaurants, cafes, gyms, grocery stores. There is a metro station right at our university, so you can reach the campus from even from the eastern Helsinki area, because this metro is very fast and very reliable. There is a new tram line also linking Otaniemi campus to northern locations of the capital area, and obviously we have highly functional bus connections. So let's next talk about the master's program more in detail. So the name of the program is Electronics and Nanotechnology, and there are sort of a lot of mega trends in the world that are related to our program, like integrated circuits, wireless communication, nanotechnology, nanosatellites. So in all areas that we represent, there is a growing need for technologies and skills, and the industry is very keen to support us and offer lots of career opportunities, even during the studies and especially after the studies. And we really have strong collaboration with industry. We have a lot of research projects collaborating with industry, in which we design state-of-the-art devices and systems, and we try to emphasize practically relevant skills, so that the students really know what they do when they go after studies into the industry. And part of the teaching is really hands-on, so you get to use state-of-the-art facilities. I will talk about them more when introducing each major. And we really are an experimental program where all of the majors are concentrating on the practical hardware issues mainly. Not so much software in our program, but hardware, IC circuits, and sensors, and all kinds of devices that we actually make. So this program is organized by the Department of Electronics and Nanoengineering. So the name of the department is a little bit different than the program. And as I said, these megatrends drive our research, and also because we have expertise in these areas, that is what we teach, and this really gives good skills and capabilities for making a better future and tackling the important challenges that are present in our modern society. We really do hardware. We have heavy collaboration with industry. And one of the things that you might want to know about the studies in Finland and in Aalto University is that lecture courses, most of them have some part that is based on continuous evaluation. So there are a lot of practical exercises or group work or lecture quizzes and different kind of weekly sort of assignments that are part of the evaluation of the course. So in addition to exam, we most of the courses use this continuous evaluation also. Teaching heavily relies on research. Obviously, the professors and lecturers have their own research areas and bring the latest information from the research side into the teaching. Most majors also contain laboratory courses, so you can get hands-on experience on the tools that are necessary in your field. And students also at some point of the studies will have access to world-class facilities like Micronova clean room facilities and some world-class software like in IC design. There are industrial tools that are very expensive. The license fees can be €1 million, but our students can use these software packages within their studies. And most majors also have individual projects where you learn some aspect of your field more thoroughly. And obviously, the final master's thesis is also usually an individual and experimental project that you can do either in the university or in company. That is very common in our university that the students find their own thesis project in a company and do it with salary. So the structure of the program is so that major studies contain most of them are lecture courses, but as I said, there are also projects, laboratories, and other types of courses that you can take. We have a few joint courses in the beginning, the first fall of the studies, but most of these courses are field specific and most also have quite a wide variety of options, so you can choose your courses based on your needs and sort of design your own major in that sense. Then there are elective studies, 25 credits that you can freely select from any Aalto course. So that includes business courses and language studies, and there might be some limitations to the arts side, especially because the number of students is quite low there, so they cannot take everybody, but probably there is some opportunity to include some design aspects, especially in the technological side. And then there is an master's thesis project, which is an independent research project done either for some research group in the university or as I said, in a company. So this is 112 credits total. And after that you can graduate as a Master of Science in technology. And next we go into the majors. We have 5 majors in our program. We just launched one this year. So originally we had 4 majors, but now we have 5. So one of the fields is microelectronic circuit design, and this includes studies in electronics and all the tools that you need to actually design modern integrated circuits. And practically all of the different fields of electronics are included, so like millimeter wave, radio frequency, analog and digital designs are all taught in our courses. So you can select your focus, but there is some common ground that you need to develop for all these fields. And in the research side, there is at the moment, what I know about this is that there is some focus, for instance, on the 6G circuits, so the next generation of wireless communication that is still in the research phase. So that is one of the focus areas, and digitalizing radio transceivers and also sensor electronics is very important in at the moment. Then there is a microwave engineering. This is also one of the old majors. So this focuses on antenna and radio frequency systems, design, simulations, measurements, and obviously nowadays the wireless communication is obviously one of the key areas, but there is especially heavy work on the antenna side to design antennas for mobile phones and antennas for different solutions. So radars are also one of the applications of this field, and the whole area studies the propagation of electromagnetic waves and how you can calculate and design based on those calculations, how you can design antennas and wireless systems. Terahertz frequency, what is used, for instance, at airports for scanning, is one of the fields. It can also be used in health purposes. So there is a lot of studies on that too. And this is the new major, so wireless and RF engineering, and this is meant for students that want to know more about building whole communication systems. The microwave engineering focuses on the devices used in these communication systems, but the wireless and RF engineering also adds courses from another program which is closer to the computer science, which involves the protocols of the wireless communication and things like that. Photonics and nanotechnology I am part of this field, and we study optoelectronic and photonic devices, solar cells, and we are the only place in Finland where we can manufacture gallium nitride-based materials, which are used in modern LED lighting, for instance, and that is one of our focus areas. And novel 2D materials like graphene is under heavy study. It also can be used in future electronics solutions. So there is a lot of effort in 2D materials. Micronova Center is where we are located. This is in a different building than the rest of the department. We are at the moment 7 professors there, and we have the largest clean room facility in Northern Europe. You have to go to Belgium to find a bigger one if you start from the north of Europe. And if you are interested what you can find in these facilities, we belong to this larger collection of infrastructure called Otanano. So you can find that web page of the whole consortium, and Micronova is part of that. And on the right you see some of the components that are being built here in the clean room. And the fifth is space science and technology. So there are 3 professors in this area, and they focus on space technology, Earth observations, phase physics, and radio astronomy. And we operate the only radio observatory in Finland, which is at the bottom, Metsähovi Radio Observatory. And there is also a picture from inside the observatory on down right. But also we are involved in space physics studies like Rosetta and Planck missions, and JUICE mission that is the newest. So Jupiter Icy Moon Explorer. There are some instruments that have been made here that are traveling with these ESA sort of probes. And we also have built several satellites, Aalto 1, Aalto 2, Aalto 3, and Suomi 100, which is a celebration of Finland's 100 years of independence. So Suomi is Finland in Finnish. So that is the name of the country here for the Finnish speakers. And as I've mentioned several times, we have world-class facilities where we can do research and teach students. The electronics and ICT facilities contain antenna characterization. If I go back, I think there was a photograph. This is from the it is sort of a muffled room where you can study the propagation of electromagnetic waves and measure their properties. Electronic test labs where there is a variety of modern tools to test your circuits that you have designed and built. For satellites, there is a space lab, clean room, and also a ground station on the roof of one of our buildings. The ground station is for communicating with the Aalto satellites and Finland 100 satellite, so we can get the data back directly to the laboratory and analyze the data coming from the satellites. And Metsähovi Radio Observatory, it was not part of the first image of the black hole, but there are plans to include the Metsähovi Radio Observatory also into a international network of radio observatories. So the development is ongoing on that sense. And Micronova, which belongs to the Otanono infrastructure, has really fine facilities for actually making optoelectronic and electronic circuits and devices. So you can do that in practice. Internship and career opportunities are various. Employment rate is very high. The latest poll from the graduates indicated that 85% of the students, when they are finishing their studies, they already know where they will be going, either to work or study for doctoral degree or some other plans that are already set. And there is growing need of workforce in our fields, and if you have been following the international situation, for instance, for semiconductor industry, there is a very large need in Western Europe and all the Western world to ramp up the production of semiconductors and electronic circuits so that we can be not so reliant on some players that are very dominant at the moment. A lot of our students continue to doctoral studies, like 30%. And there is a lot of support for your career, and the slide lists here many of the opportunities, and you can find more by going into the Aalto web pages and finding out these different programs and events. Here is some of the companies where our graduates have been going. So this is a exhaustive list of the high-tech industries in Finland and in Europe and also worldwide. So there are some of these companies have operations worldwide. So the opportunities are not only limited to Finland, but throughout the world of high technology. And next, I will give the floor for Gayankana, one of our students. Please tell your experience as a student here in this program.
Okay, thank you, Professor Maku, and good evening, everyone. I'm Gayangana Dilaratna, and I'm from Sri Lanka. I'm a second-year master's student following the program of major in microelectronic circuit design, and along with my studies, I am also working as a research assistant in the electronic circuit design group at Aalto University. Okay, I'll give you a brief background about myself. I completed my bachelor's degree in electronics and telecommunication engineering, and I worked for around 1 year in the electronic industry. And while working in the industry, I wanted to enhance my knowledge in the field of microelectronics, especially focusing on IC design. Therefore, I searched through the websites of different universities and checked through the curricula of the master's programs on electronics. And I also walked through the Google Scholar profiles of different researchers in these universities to get an idea on what sort of areas that they are working on. And during my search, I saw that the Department of Electronics and Nanoengineering at Aalto University conduct research in a vast area of electronics that includes analog RF and digital IC design, microwave engineering, photonics, and space science. And I was delighted to see that these different domains are offered as majors in the electronics master's program of electronics and nanoengineering. And I went through the curricula of these majors and saw that the courses were very interesting and they were integrating with my interest. And after doing my research, I submitted an application to Aalto University, and luckily I got admitted there to pursue my master's studies. Initially, the university conducted several webinars on informing us how to get used to the living in Finland, finding how to find the accommodation, and also providing information about how our program is progressing, and so that we can make ourselves ready before coming here. So these webinars help me to understand more about Finland, more about the life of Finland. And university also provided us with student tutors who helped us to settle here. So my tutor even came to the airport to pick me up, and he even picked my keys of the apartment, and that helped me a lot to settle in Finland. And first, we had a wonderful orientation week where we had different tours inside the university, a lot of fun activities that were organized by the different guilds, and there were several workshops that helped us to plan our studies. And during the orientation week, I felt very warmly welcome to Finland, as well as I was able to make many friends that in the program. Okay, now come the most interesting part. It is how my studies have progressed in Aalto University. And for an example, I'll start with the course structure. So the course structure is organized in such a way that there are compulsory courses that we have to take, and as well as there are some electives that we can take on top of our major. And usually, in the first semester, we have introductory courses that cover the basics of the major and that they lay the foundation for our studies. And then, as the academic year progresses, we start to dive deep into the subject. So, for an example, even if you are away from the studies for a while, you may be working in industry after your bachelor's. But this with this introductory course, and you might feel that you have been away from the studies for a while, and you might have lost the academic touch. But these introductory courses will help you to regain the academic touch, and as well as that will make you ready to follow the more advanced courses. In my case, as I did the major in microelectronic circuit design, in the first semester we had courses like electronic circuits and electromagnetics that laid the foundation of the major. And once the academic year gradually progresses, we had courses on IC design. And one of the most interesting course I took was IC design project. And in that course, I got the opportunity to work under the supervision of a PhD student to work on a real work project that is already happening in the research labs in Aalto. And depending on the major we select, we are given with an academic advisor who is generally a senior lecturer or a researcher in the department. And we can seek assistance from our advisor to build our study plan. And if we have any issues related to our studies, we can discuss them with our academic advisor. And we also have a planning officer for the program, where we can seek assistance on non-technical issues and how about any issues related to course registration, or but if we have any issues while we are progressing with studies, we can always discuss them with our planning office, and they are very welcoming and ready to help every time. I'll tell briefly about how the courses progress in the Aalto University. And in most of the cases, the lectures are very interactive. They support on-site learning. And it is not like you have all the lectures together and you cram up everything before the exam and you write the exam in the next day. So it is not happening like that. Instead of that, we have lectures that focus on everyday learning. There are different activities such as pre-lecture quizzes, post-lecture quizzes, simulation assignments, projects, and presentations. Therefore, through these different sort of activities, we not only develop theoretical knowledge, but also we can develop soft skills that would be beneficial to shape up our careers. And our department is also equipped with state-of-the-art laboratories where we can perform different measurements. And there are different courses that we can enroll to and get hands-on experience on using different tools available in these labs. And we also have many state-of-the-art software to do design and simulations, which I believe is very important to pursue our careers in the future. The university not only focuses on academic activities, but also organizes different events such as careers events, alumni meetup that help us to grow our network. And through the career events, we can meet representatives from different companies and get an understanding on what sort of skills that we need to develop if we are interested in joining the company after graduation. And also there are some programs that we can apply and get the mentorship from a company in Finland to adjust ourselves to the working culture in Finland. And other than that, there are many events and workshops organized such as CV writing, facing interviews, and many more that make us ready for the job market. Finally, I would like to say that applying to Aalto University is one of the best decisions I have taken in my life, and I would not hesitate to recommend anyone to follow the program in Electronics and Nanotechnology Master's Program to anyone who is interested in pursuing a career in the field of electronics. And thank you for listening to me.
Okay, thank you, Gayangana. And he will be available for the question session if you have any particular questions for him. And next, I will give the floor to Jenny Tulensalo. She is our planning officer and handles all the practical issues and administration of the program. So please, Jenny.
Okay, thank you. Thank you, Markku. Just few things here listed. The most important, obviously, is the general admissions instruction page. All the very detailed instructions concerning the application process is described, and it concerns all programs in Aalto. So all programs follow the same schedule and same instructions. At the moment, we have one annual application round every year. The application is usually at the end of the previous year. So studies always start in September, at the beginning of September. And for example, now in 2024, for studies starting in September 25, the application round starts at the end of November already, and the deadline is towards the end of December. So some variation there, but usually at the end of the year. But it's good to always check from the admissions pages what is the next application round. On this pages, like I said, I can find very detailed instructions about the application, but also on tuition fees and scholarships and all the general admission requirements. Regarding the details of the application process, the Aalto General Admission Services are the best experts in helping and assisting with that. But especially if you have questions about electronics and nanotechnology program, you are very welcome to ask us also directly by email in this address here, masters-elec@aalto.fi. so we can also respond there in more detail if something comes to mind about the studies and different options in the majors and so on. So you're welcome to also ask later after this webinar presentation.
Okay. And next, we have the session where you can ask questions in the Q&A, and Jenny will read out the questions, and then me or Gayangana will answer, or Jenny directly if it's related to practical application issues.
Yes, so feel free to use the questions and answers box for your questions if you have something specific in mind. Okay, so there is a question about when are applicants informed about admissions. So in the application instructions page, there is a timeline describing the general like steps of the admission process. So the final results are published usually at the end of March or at the beginning of April, depending a bit on the year, but around that time. So there is one moment when the results are published. There is also a possibility for later. There is a reserve list option also in case applicant is placed on the reserve list. So then the admission decision might come later as well. Okay, another question. I'll just read them aloud because we will be placing the recording in YouTube channel, so that we can also then include these questions in there. So is it possible to manage a part-time job and the master studies at the same time? I don't know if Gayangana, if you have some answer, I can also answer this, but in case you have something you would like to comment to this one.
I would say if you can manage your studies as well as work, then there's definitely a chance. And also, if you consider second year, the university also offers some summer training positions, as well as then you can continue as research assistants in the department, as I do. So in hindsight, if you can manage, I think it is possible.
Yes, it's we usually what we most commonly answer to this one is that try to play or try to organize your life so that you don't have to, or preferably so that you could focus on studies, especially during the first year for studies only. But then, like Gayangana said, it's especially from the first summer break onwards, students might be already working part-time, especially if they have been working in the summer at the departments and so on. So it happens. So it's a lot of work, but it's possible. Another one, I'm interested in semiconductor science. What specialization can I pursue?
Okay, maybe I will answer this because I am representing also the major of photonics and nanotechnology. So this is an excellent place to study semiconductors, and we have been increasing our collaboration with the Finnish semiconductor industry. We have been for 2.5 years now been negotiating about with the Finnish semiconductor industry, and they are strongly supporting us. If you want to look, you can try to find semi-summer name from Aalto pages, because in 2 years now we have had I think first year we had 14, second year we had 12 positions that the industry paid for. but the students that were selected for these summer positions joined the research groups and work at the laboratories in Micronova, and this is directly related to semiconductor industry. And we also this year launched a new minor, a micro and nanotechnology minor, which is designed together with the Finnish semiconductor industry to support any other students that might have some inclination towards semiconductor industry, but want to also develop some other competencies like mechanical engineering or software engineering, and then they want to add some experience on semiconductor industry. So we have designed this minor for those people with the industry.
Any further questions? We still have some time left. Okay, at what point of the admissions process you need to decide your major? I can maybe respond to this one. We instruct if you are looking at the application instructions in the program page for applicants, we ask applicants to already indicate which major they are primarily interested in their application. So you should already express which major or majors you are particularly interested. It's important for determining like the background, sufficient background and all that in the admission stage. But it's not binding in a sense because we ask then before the studies start, usually during August, what is your like final decision for your major? So that's when new students need to decide that, because then when you start with the first courses, you should already know which one. So it's many times we have new students who are still kind of contemplating. Let's say so that many new students already know for sure what major they are taking. I would say majority, but some are still maybe contemplating between two options. So August is then the latest point when it needs to be decided.
Yep. Previously, when we started the program, we had only these common courses in the first fall. So then it was manageable to select the major during the first autumn. But now we have given more flexibility for majors so that there are already some courses that are major specific during the first fall. I would say that maybe if you try something out for the first fall and then want to jump into another major, it is not impossible. It can be done, but it is then more work because you have been missing some courses already.
Okay, then another one. In the photonics and nanotechnology major, is there a chance to get hands-on experience in the Micronova labs as a part of the courses?
Yes, there is. Especially there is a course called Micronova Laboratory course, where different groups have some assignments that are using real measurement tools, and you get to go to the labs and experience. And if you choose, you can do this special assignment, which is an individual project. What you can do with a research group, and it is usually very practical, hands-on work in Micronova. There is no clean room specific course at the moment, but there are some occasions where you might get access to clean room, but it is very professional environment. You need training in practices and safety and many things like that before you can enter the clean room. But the measurement labs are obviously utilized also in teaching. So are there no more questions?
Not at the moment. We can still wait a few moments if something pops in someone listener's mind before we finish.
Yeah, we have 4 minutes left, so I would also like to say that Finland is a modern, democratic Western country which has a very nice nature. We are in the boreal forest area, so much of the land in Finland is forest, and there are a lot of national parks and other opportunities to go into nature and enjoy the nature also during the time living in Finland. So that is one. And many people have said that the Finland has the cleanest air in the countries that they have visited. So it's a also very environmental friendly country.
There's actually one I kind of almost missed out as a continuation to one question. I'm not sure this is maybe partly answered already, but I'll still read it aloud. Is the nanotechnology specializations practical or theoretical? Are students allowed to use the state-of-the-art synthesis and characterization tools and equipments?
Yeah, the answer is quite the same as for the previous one, that there is one laboratory course where you can experience different groups and their work, and there is the individual project, and also obviously the master's thesis is especially if you want, so you can also specialize in fabrication issues and get to use real tools to fabricate, for instance, 2D materials, to fabricate 3-5 semiconductors. We are the only place in Finland where we can make gallium nitride based devices like the modern LEDs. And the clean room for the processing of actual devices is also accessible in these special assignment and master's thesis projects, but not in any sort of a lecture course. Okay, it seems to be 4 o'clock. So I would like to thank Gayangana and Jenny for appearing here with us, and hope that everybody that has been watching is considering the application to Aalto University and to our master's program. So kiitos, which is thanks in Finnish. So we will end the webinar to this. Thank you.